Hello everyone, and welcome to today's webinar on ISO FDIS 10012, Quality Systems Requirements for Measurement Management Systems. My name is April McMullen, and I'm the Standards Development Manager for the UK Mirror Committee of ISO TC 176 SC3, which is responsible for ISO 10012. If we could move on to the next slide, please. Just some housekeeping before we begin. So this is a listen-only online event, so your microphones and cameras will remain off. But do feel free to use the reactions button at the bottom left of your screen. You'll also be able to zoom into the slides for more details. Please do feel free to submit your questions as well using the question button at the top right of the screen. If you experience any technical issues, please do feel free to report these through the same question box. The chat box will also be monitored throughout the event. Following completion of the webinar, there'll be an opportunity to complete a feedback survey, and in a day or two you will also receive a link to the recording and a copy of the slides as well. Just to be aware, this is also a CPD accredited webinar, so do complete the survey to request your certificate. And lastly, you can find out more about BSI's upcoming events by scanning the QR code that's currently on screen now. Thank you. If we could just move on to the next slide. Thanks. Just a reminder of the agenda for today as well, which should include plenty of time for some questions at the end. Before I hand over to our speakers, some of you might have spotted already that we will be referring to the standard today as ISO/FDIS 10012. And for those who aren't aware, FDIS is short for Final Draft International Standard. So it's the final stage before a standard is published and contains all of the technical changes of the revised standard. So we are just waiting for the publication date from ISO now, but it shouldn't be too much longer. And for those interested, the ISO FDIS 10012 is available to buy as a pre-order through BSI. And once the standard is officially released, you will automatically receive a copy of the published standard at no extra cost. And I can share that link with you later on. Next slide, please. So I'm really pleased to welcome our speakers for today. So first up, we have Alison Norwood, who is a metrologist at Sellafield and chair of the UK Mirror Committee for ISO TC 176 SC3. I'd also like to welcome Don Malozzi, who is a metrology specialist at the National Conference of Standards Laboratories International. And we have a third speaker today, Sharon Fenson-Rimmer, who's a member of the UK Mirror Committee for ISO TC 176 SC3. And all three of our speakers today were part of the ISO Working Group 27, responsible for the ISO 10012 update as well. So thanks very much again to all of our speakers for agreeing to take part in this webinar. I'll hand over to Alison now, who'll be able to give some background to the revision. Next slide, please.
Go to the next slide, please. The biggest question that we were asked was, why is there a need for this new standard? Why has it become a type A standard rather than a type B standard? And what difference will that make? Normally, it was part of 9001 and it was just a sub-document. People could use it, not use it. To be honest, it was being abused as part of being a substandard. When it was made a type A standard, it meant that people have to be accredited to it and they have to be worked to meet the requirements of it. What we're doing with this standard is we're setting up a measurement management system for the future for organizations do this, what the problems are, where things come from with all the different standards. There was an issue with 17025, but Dom's wanting to speak about that, I believe.
Yes, thank you. Thanks, Alistair. 17025, for those you aren't familiar, is the standard that's used by calibration and test laboratories. And it is a technical standard for laboratory operations, which includes calculation and measurement uncertainty, records that are required, how to report data from a calibration or a test operation. And it's used primarily, again, by laboratories involved in the calibration and test services business. Companies providing services, repair organizations, and it could be any repair organization that provides a technical component of the service. So they are not the same standard, and the introduction of 10,012 has no effect on 17025. That's been a question we've received multiple times. We're going to treat that a little later in another slide, but 10,012 is not changing the requirements or needs for 17025, nor is it changing how 17025 is applied in industry.
I think that's a really important part. It's not a silver level of 17025. It's a different standard complete on its own. It's a production standard. It's not a test measurement standard in that way. Could we have the next slide, please? Why is that? So it's been transformed from a guidance standard to a requirement standard, and it ensures that the standard can be used to demonstrate conformity. So when your customers ask you, how can you prove that you've measured this properly? How can you prove that you've done the right uncertainty, that you've done the right types of measurement, that all your measurements are correct? That's what this standard's for. When Sharon, when Dom and I wrote it, we wrote 105 shall statements. These were just to help understand people who don't normally work metrology. This standard was written for non-metrologists. And because it was written for non-metrologists, there's a whole lot of shall statements. It's 55 pages long and 3 annexes. 120 it really is there to help. It's a standard that's there not to bamboozle you, not to make you difficult. It's a standard there to help you. Sharon, what do you got any thoughts on that one? You're on mute, Sharon.
Emphasize it's that guidance, it's to support and to give that steer with what's needed within that production area, and those are elements that all dovetail together to produce that output.
So it's designed to control the systems used inside an organization in a measurement management process. So it's looking at things like, how often do we calibrate? Who's able to calibrate? What kind of test equipment are we using? What's the uncertainty of those tests? Those are all the questions that normally don't get asked in a production environment that we're saying 10012 is there to do. And then there's another bit about 17025. Dom, do you got anything to say on that one?
Yes. One of the things we did do is in clause 8.4.1, we put a note regarding 17025. And I'm going to read it. It says organizations implementing ISO IEC 17025 can demonstrate conformity to the testing and calibration requirements through documented information produced for ISO IEC 17025. What this means is if you have a cal lab or a test lab providing you services and they meet 17025, they're accredited to 17025. The data we're asking for in 10,012 is no more than they're providing. We're not asking you to add to the calibration laboratory task. We're not the only time you have to worry about the calibration laboratory task is when you have a calibration lab inside of your organization. And we discussed that in, I think, clause 8 further. But for those of you who don't have an internal calibration lab or internal conformance testing, when a company provides you a 17025 certificate of calibration, a test, it has all the data you need to meet the requirements of 10,012 the way it's stated. And there is no need for them individually to be 10,012. There is one exception, which Alice is going to mention in a minute, so I'll mention it. If you use a calibration lab that also repairs your equipment, they have to take into account 10,012 in the repair process, not the calibration process. So the documentation needed for repair, the methodologies needed for repair have to comply with 10,012 when they're doing a repair, because 17025 doesn't discuss repairing equipment. It only discusses the calibration and test functions.
Come on, the next slide, please. So the standard was part of 9001. It was a support standard, and now it's been made a type A standard, which means you can be audited, you can be held accountable against it. So when you're audited, people can say, how are you fulfilling it? Whereas before it was, well, are you fulfilling 9001? Are you doing this sub stuff? It's a standard complete on its own. It's a type A standard. And it was designed, we had the Americans in the group said they wanted this from the outside. It works equally well with 14025 or the ANSI standards. So it doesn't need 9001. It will work with any of these other standards and fulfill the same job. So that was a thing that we worked really hard on as a group. As I said, it's not a lab standard, but it's a production standard. It's for use. I kept on, when we were talking about this as an organization, I kept on referring back to, and this will make Dom smile, a washing machine manufacturer in Italy and what they're doing to make those washing machines, the fill rates, the production environment. That's what we went back to. Went back to a production environment and how a production environment would do it. So it's a production standard. So it's used in test equipment for production. It's used for measurements for production. It's not meant for, I'm going to calibrate that multimeter. It's to do with, I've got that fill thing that I need to get calibrated. Go to the next slide, please. Clause 4. Does Dom or Sharon want to speak about clause 4 before I? Nope.
I'll defer to Sharon.
Or I'll have something to say.
Okay.
You go, Alistair.
Right, so clause 4. So what's really important is this, is the organization must, it's imperative, you must establish, implement and maintain. So you have to have people who have the right organizational ability, who are the right leadership, who are authorized to do this. So you can't just throw it onto someone from the shop floor and say, yeah, get on with that. This needs to be driven from senior management. Only senior management can authorize people to do this. Only senior management can say, by their leadership, clause 4.3 says, they need to establish a scope. So this needs to be driven from above. So this is not a bottom-driven thing. This is a top-driven organizational thing. We need to set up the whole organization so it does it. So the organization shall establish, maintain, implement, and improve continually. This isn't, when I teach metrology, I speak about, I used to have a 1973 Ford Escort, and it was expected to last 60,000 miles, and then the engine would stop working. And there was engine rebuild shops in every single town in the UK. When I got a Vectra a few years back, I got rid of it after 180,000 miles. Not because the engine stopped working, but because the standards had improved so much. The measurement standards had improved so much. And that's what this standard is here to do. We're here to drive the measurement standards up. And that's what your customers want. That's what your suppliers want. You want to drive the measurement standards up. Next slide, please. Next slide, please. Clause 5, the leadership within an organization. This is really important. So they must promote this measurement management system, and they're looking at what you need to do, how you need to do it. The top management is required to establish a measurement management policy. So how are we going to measure it? what we're going to do with it, and there must be that commitment. There's no point in taking the standard on half-heartedly. There's no point in taking the standard on and thinking, yeah, well, we can get around this one. We'll get someone to write it and we'll just ignore it. This one needs to be top-driven, driven by top management. And as a senior auditor, Sharon, I'm sure, has thoughts on top management driving standards like this.
Thank you, Alistair. It is about taking ownership, taking responsibility and owning it to ensure that there's sufficient resources to implement it, and not just to implement it, to embed it and to maintain it, that you have the right individuals with the right numbers of staff, with the right skills and the right knowledge to ensure implementation, embedding and maintaining. And it is that continual circle, and it is that leadership, that top level leadership, that takes that ownership and that responsibility at all times. Even when things are not rosy, it is about that leadership and responsibility.
And that's important.
I think one other important thing here, Sharon, that you said about top management assigning activities, it's important that people realize this is not a problem for the quality department only.
Absolutely.
This is the engineering departments that's designing product, the logistics people that are maintaining the product, the repair depot that are doing special operations in the field. Everybody's included. And that's something that top leadership has to assign people from each organization. Saying it's a quality standard, so it's a quality problem, is not the answer in this case.
I think to emphasize that, Dom, and that is a really valid point to emphasize, this is for everybody to be involved in, everybody to take ownership, and to use that phrase, quality is for everybody, not just those individuals within the quality teams. It's for everybody. Every single piece of the jigsaw should be having that buy-in to this and taking that responsibility.
There has been a question asked in the questions part of it on 17025 and 10,012. I think we'll answer that question at the end, but the answer is they do different jobs. Just because you're 17025 doesn't mean that you'll automatically meet 10012. They do different jobs, and we'll be talking about that later on. Is that how you see it as well, Dom?
Yes.
Could we have the next slide, please? Planning. The introduction of an MMS, maintenance measurement management system, within an organization is going to be complicated. It's going to be difficult. We're looking at lots of moving parts, but it's something that needs to be planned. For example, if I'm making a measurement, if I'm looking at, come back to my example earlier of a washing machine manufacturer in Italy, and I'm making a pump as part of that, I need to know, is the person using the meter trained? Does he have the correct training? How often is that meter calibrated? What's the uncertainty of the meter? Is it the right standard to be using? How is it documented? How is that documentation kept? How do we keep the measurement? How do we, whole load of moving parts are happening all at once. So the planning is a big, important part of it. There's no point in doing this if we're not prepared to do a lot of planning and working out how often, if I have a standard and I'm using that standard, how often am I getting that standard calibrated? Is it traceable back to national standards? Do my people know that it's traceable and know what to do? Do they know everything about it? These are all questions that we need to be talking about as planning. And the act of planning should be something that we're doing continually as part of this 10012. Do either of my two colleagues have any thoughts on this?
Yes, I think that it's important to realize I know a lot of industries have developed silos, the engineering department, the quality department, the test department. I come from an industry that doesn't do that. I came from the defense industry and spent 39 years in a major defense contractor. And one of the things that you could tell that this was serious to the organization by was the fact that the organization would have an introductory meeting when a new product was being introduced, and everybody would be around the virtual Zoom table, quality, engineering, metrology, sustainment, production support, manufacturing. All those organizations had input, and that's what ISO 10012 really says, is everybody needs to have an input and a say on the process, and make sure that the processes are integrated so that they run smoothly between organizations.
Can we have the next slide, please? Clause 7 is really an important clause. What it says is this: we need to have the right resources, we need to have the right training, we need to have the right everything. To have this, we need to be doing it and continually determining. So when I'm saying this, if I'm going back to my washing machine example, if I'm doing this, I'm looking at the equipment I'm using and saying, is there better? Is there better uncertainties? Is there a better measurement I could make? What is that better equipment? So it's moved from a lab standard to a production standard, because only the production people know that, and they know the right types of equipment to buy. So it's moved from, am I getting it calibrated properly, to am I getting it done properly, to is it the right standard to be used? So am I using the correct measurement equipment, and am I getting it done properly? And it goes on further to outline that all personnel have to have the correct training. So we need training records for everything, and the right environmental conditions, and the right other conditions. Everything needs to be right. Organizational knowledge is also covered here. So we need to say, as an organization, we need to be doing this, and we need to be looking at this. It's really all to do with planning, documenting, organizing it. As I said, there's lots of moving parts, and it's impossible to implement this standard without knowing what these moving parts are, and without having spent time as an organization looking at these moving parts and looking at what they could do. Do either of you have any thoughts on that one?
No.
No, I think you've explained it well.
You have.
Can we have clause 8, please? Right. So I want to speak about one of the sub-clauses that's not in this, 8.1.2. And 8.1.2 is quite a unique clause, unique to 10012, and it will become, as you're in your workplace, this will become a major thought for you. It deals with cybersecurity and control of materials that shouldn't be there, bolts that shouldn't be there, bolts that you can't trace. Is your cybersecurity correct? Are you getting, if you're buying a piece of equipment and it has firmware embedded in it, is that firmware correct? Are the bolts holding it together correct? Can we trace them all back to the original manufacturers that they came from? And that's a clause in this that we spent a lot of time as a group putting in. It really is an important clause. So this section controls the ongoing control. So what do we do day to day? How does a system look day to day? What does the requirements look day to day? How do we do that day to day? That's in section 8. What do we do day to day to show that the MMS is working properly? And I know that you took a lot of active part in this, Sharon, and a lot of active part in this, Dom. Do you have thoughts on this one?
I think it's to emphasize, it's that day-to-day running, it's that day-to-day activity that has to be continually evolving. And and providing the assurance and reassurance, the evidence that the activities are fit for purpose.
I think the important thing, what Sharon said there, is evidence and the correct people. This is going to bring calibration out of the Cal lab and put it on the shop floor. The shop floor people need to understand uncertainties, need to understand traceability, all that sort of stuff, because it's part of this work. Sorry, Dom, I interrupted you. I do apologise.
No, no problem. I think the third bullet here is kind of important, that you need to control your external processes and make sure they confirm what your contractual documents require. I think a lot of companies now look for the lowest price without looking at, does this item we're buying meet the quality we need to make our quality requirement work. Everybody has a requirement for what they want the quality of their product to be, and that can't be done. You can't add that in later. The items being included have to have the quality needed to do that up front. So they have to be measurable, they have to be defined, they have to be integrated with the engineering process and the manufacturing process. So it's kind of important to realize that that statement means a lot to how an organization functions.
Could we go to the next slide, please? So the design inputs and outputs need to be considered. So it needs to be a holistic view. So the organization will consider design and development outputs as it's doing it. So when I'm designing something, if I'm making a piece of equipment, I need to be saying, and I'll forget about how to test it. I need to be designing into that. How do I test it? How do I measure it? Built into the design of that. 5.3.5.2, the measurement where we look under the hood and see what the measurement process is. How do I measure it? What do I need to measure it? Do I have the ability to measure it? That's really important. This clause 8 contains all the important information. The section goes on to speak about documented information. We need to be storing that documented information. We need to be making sure that individual departments are able to access that individual information. This is not siloed. Don was speaking earlier about silos. This standard's about breaking silos down and having other areas do other things. And the silos, Sharon, you got a thought on this one? I'm starting to wax lyrical and I don't like it.
When we often work in silos, it's, if you think of the analogy of building a bridge, everybody has to work together for that bridge to meet together or to reach the other side. So everybody needs to work together. Everybody needs to be communicating, because without that communication, things will not come together, and it is about ensuring that all of those teams know what each other is actually doing. That communication, if something has failed a calibration, why has it failed that calibration? Which team is going to be working on that to sort out that problem? And it's about that communication.
Yeah, I think the other thing that's important too in all this is a lot of our manufacturing colleagues have heard the terms tolerancy and accuracy in measurements. And this measurement process in 8352 describes in a way how to incorporate those into a measurement uncertainty budget. And I think that that's one of the things that people are going to find is different from a terminology point of view than what they've done in the past. When I first started in the industry in the 70s, tolerance and associated terms were what everybody used. But now in the calibration industry, measurement uncertainty is what we use. It's an extension to take a realization the measurement uncertainty world, that you have a distribution of measurements that are affected by multiple elements. And I think that one of the things that has been lost in the manufacturing side is tolerance was considered an element in and of itself without any consideration to the influencing factors like environment, changes in method, changes in equipment. The measurement uncertainty process includes all that and makes it an integrated result that is statistically valid. Did I say that right, Sharon?
You did.
Sharon, when we were setting up the committee, Sharon was our expert on uncertainties and our expert on statistics.
I think there are many elements when we talk about uncertainty that contribute to that end product, that end value, of which some of these are not measurable, and it is taking that into account regarding the tolerances or the actual result.
You know, in fact, the last line of this that talks about operator capabilities is an interesting one, because certain people are better at certain tasks than other people, and you've got to take into account that if you're not going to say only one person can do this on a production line, you've got to make sure that the process is designed so it eliminates as much of the operator variability as you can do. And from that point of view of a company, that's a good thing to do, because it means if somebody is out sick or on holiday, they don't affect the capability of the company to produce a quality product. If you design properly, you can get around a lot of that. I mean, the classic discussion is how to calibrate a torque wrench in the cal business, and we all have the little click type torque wrenches in our labs, and somebody grabs it at one end, somebody grabs it at the other. They change the axis of measurement.
The new standard on that, Dom, is you put it into a machine, hit the button,
Yep.
and it does it automatically for you now.
Yeah, I'm familiar with it, but again, there's still companies that still applying the wrench have the problem of people using it correctly.
Using it's the biggest problem.
Right,
And
and that's where you have to
take
take into account operator capabilities, because you should design your user process to eliminate the variability related to the operator, if you can.
And to come in on that, Dom, that comes down to minimize that what we would call inter-operator variability. That comes down to training and competencies, and to ensure that all of your staff are trained and competent to do a procedure.
And that's important too, from the point of view, Sharon, I think that you want to reduce the amount of material you make that's non-conforming.
Absolutely.
And accounting for operator variability in processes helps you get away from, increase your non-conformity rates and get away from those and reduce their effect.
We're starting to run out of time. Can we move on to the next slide, please? We've only got so long. Clause 9. It's impossible to have this without us having to evaluate it. This standard's all about do tell, do tell, do tell. It's a virtuous cycle. When you start to implement it, you'll start to say things like, well, if I bought a better one of these, I could increase the uncertainties and I could make that better, and maybe not have to get it calibrated quite as often. Or if I had the better boy better trained, he could make it better and I wouldn't have as much work rate. This is all about how to make things better by performance evaluation. It really is an important, it's one of the highlights of this standard. Looking at customer satisfaction. What do our customers think of us? Do their customers think we're making rubbish and producing rubbish and they're only buying it because they have to? So it's looking at what the customers want and what the customers think. And there's in 9.1.3, there's a list of criteria used in that evaluation. And we had an internal audit program. So all of that is contained in clause 9. Clause 9 is a really important clause. Any question, any thoughts on that one, people? No. Can we have the next slide, please? So So we have 3 annexes. Annex A, we're looking at periodicity. Why do we get something calibrated? How often do we get something calibrated? And why do we decide on that periodicity? And it looks at some of the strategies behind it. Obeyance, looking at it regularly, the mathematical model. And we were really fortunate. We have some French colleagues that brought out an ORPET document, an ARFNOR document, AX07, which was fantastic. And there was Gaussian distribution. So we looked at that and gave people who normally don't understand it, the mathematics behind it and what to look for and to help them. This standard is written to people who don't normally do this sort of stuff and pointing them at direction, saying, if you do this or if you look at this, it will be where to find it. So there's a lot of documents referenced in it that will help you find things. Either you two got any thoughts on this, on that?
I think we've provided if you look in the bibliography, we provided multiple references to providing calibration. By the way, periodicity in this case in the US would be called calibration interval.
Yeah.
So those you deal with US companies will hear the term calibration interval. That's what they mean by periodicity. We've provided multiple references to people to help them understand this in the bibliography and in the notes. I think that you'll find that we've made a serious attempt to not leave people stranded with this concept and let them try to figure it out for themselves. Sharon, did you have something? Sorry.
I think to add that this appendix, the bibliography, I think is really important because it gives a lot of the background reading, the background information relating to these this terminology, which you don't actually get in 17025. So in 17025 you do have calibration intervals, you do have the point at which the piece of kit, the instrumentation, the tool needs to be recalibrated. At what point is it? From the point of manufacture, or is it at the point of it being in use, which are very different? So I think this bibliography is really important, and I think it gives a good steer for those who are using the standard.
Can we have the next slide, please? This one is purely mathematical, and all it does is help you understand uncertainties, understand where uncertainties come from, understand what uncertainties look like, and points out to all the documents that they need. The GCGM series of documents. I wrote quite a lot of this because I'm chair of SS6, Statistics Committee. This is all to do with understanding statistics, understanding uncertainty. And it's written really to help people go down that route. Dom, Sharon? No.
I think it's important to note that ISO has a whole series of
GCGM
documents that discuss uncertainty in I think it's ISO 98, if my memory serves me correctly, in the GUM, the Guide to Uncertainty and Measurement. People get scared when they open those documents because they have all kinds of things like double integrals and stuff that we all remember from college and have tried to forget. But the truth of the matter is that it's a very easy to implement concept, and it's again related to what we used to call tolerance and accuracy. So I think that if you read through this, you'll slowly find that it is not as onerous as the other ISO documents would imply. I know that the Cal Labs initially, when they heard uncertainty about 40 years ago when I started in the business, went crazy because we all lived on the accuracy and tolerance limits. But we've all adopted. There's plenty of software available to help you with these processes. It's not that difficult. I
know it's not that difficult, Dom, because I wrote it.
Yeah. It's just really
Must be simple.
important to understand that the JCGM and the ISO documents, but ISO 98, go into different methodologies. They do things that you might want to understand further.
Right. Annex C, the next slide. I want to spend time just for a moment giving thanks to Dom's friend who came on purely for this slide to help us write it.
Yeah, Bob Stern from formerly with
Bob
TSA.
Stern from ILAC wrote
Yep.
this ILAC G8 guide on this subject. So we brought in an expert and the expert wrote this. And what Bob Stern doesn't know about ILAC G8 isn't worth knowing because he wrote the book on it. So everything within this standard corresponds with ILAC G8. Could we have the next slide, please? Because we're running out of time. So many professional considered as an add-on. Many of the issues are mathematics and uncertainty. This caused a disconnect between quality professionals. So we have a Wikipedia article that covers metrology and then a bit on 17025. I would like to say, and we've had a question, if you have what we'd call a captured lab, an in-house facility, then your in-house facility can easily meet the standards that you require. If you're going external, you may want to have an external, or you may want to have it for be able to show how you do things. But the standard was written around having what we'd call captured labs and in-house labs. Dom, you got thoughts on that one? And Sharon, do you have thoughts on this one for people buying things?
Yeah, Sharon, you go first.
I think, again, it is around what's the purpose and what is it that's involved in the manufacture. If you're providing a service or manufacturing something from scratch, then you need to consider at what level of confidence you need to provide into your users, whether that's it needs to be a calibrated piece of kit which needs to be 17025, or does 10012 meet that requirement? And the two are different.
Yes,
very different.
And I think the important thing to realize is that you have to make the risk assessment for your product, and determine how you're applying these standards. People need to realize where their product fits in other people's businesses and understand what the risk assessment related to that is.
Risk assessment is really important. This is a production standard, it's not a lab standard, and we need to be getting that balance done properly. Could we have the next slide, please? We're running out of time. It's a requirement standard, so if you're introducing it, there's no paying it lip service. You need to implement it properly. Otherwise, you're not going to be able to do it, and it will take work. It will take effort. So auditors will need to be trained, asking the right questions. An organisation will need to be certified against the requirements. Certification bodies such as UCAS in the UK can be accredited to provide this service. Dom, you got any thoughts on it?
I think that the only thing that you need to take away here is that even your auditor needs to understand what the purpose of the standard is. It's not enough to say I had an audit. It's more, does the audit understand what you're trying to do as the result of the use of the standard, as I think the terminology I would use.
Can we have the last slide, please? In closing, both Dom, Sharon and I would like to say this standard's not just for metrologists or measurement experts. It brings in measurement, it brings in uncertainty, it brings in how we do things to equipment engineers, designers of new products, system engineers, product quality, users on the tools, making measurements, who've never considered themselves to be measurement people. All of this group of people is now involved in this standard. And it means that everybody now has a share in a company's success by doing the measurement properly. The new standard is an innovative development which can drive quality and innovation. And that's what it was designed as. That's why we spent 3.5 years of our life writing this standard. Was it really that long, Dom? Sharon? We wrote this standard to drive quality and to drive innovation, because we think that by using the standard, the quality of products will go up. And that's all I've got to say. Do either of my two colleagues like to say anything?
I think when this standard is implemented, embedded and maintained, and everybody has buy-in, all teams have buy-in, top management have buy-in, I think it will be the way forward.
Yeah.
I believe too that the introduction of the this version of the standard will give people more direction on how their businesses can best reduce waste. I think it will help them understand the contributions of different measurements they make in the process and how that relates to the waste that they generate in the process.
So April's going to bring us questions and we'll answer some of those questions.
Thank you so much, Alistair, Dom and Sharon. We have reached the Q&A part of the session, and a reminder that you can submit questions using the question button, the top right-hand side of the screen. I wondered if we could go back to the question that you briefly covered earlier. Do you want to talk a bit more about the differences between ISO 10012 and ISO 17025?
I'll leave that one to Dom, because Dom is the expert on that.
I'm not sure I'm the expert, but I'll comment. 17025 is specifically a laboratory standard for calibration laboratories and test laboratories. It's not a design standard. It's not intended to be used in a design function. It's not intended to be used truthfully in a maintenance function. It's strictly to cover measurements made and how they're reported to the customer for calibration and for test operations, for example, for EMC certification and similar activities, conformance certification. It was never intended to be as a general use document. 10012 is a general use document inside of a manufacturing, service, or engineering organization for them to perform all the functions of their organization. Again, 17025 is very restricted to the calibration business and the test laboratories business. That's what it was written for. It was not written to be a general use standard. 10012 was intended to be a general use standard. Sharon, you ordered some of these. What would you have any comments?
I think what I would add about 17025 is that it is when that's used within a laboratory environment, whether that's in a biological lab or a forensics laboratory, it is about the trueness of the result, the accuracy of the result, and the traceability of all components that have been involved in that final output, and that final output being a numerical value of some form, and that is where the measurement of uncertainty comes in regarding that trueness and accuracy and the tolerance, the likelihood of a result deviating from such and such a standard deviation. So from that perspective, but it is around that traceability from the beginning all the way through to the end, right down to the traceability of the calibrators that may be used to get that end point, that end result and that output.
it doesn't cover things like, is that the correct torque range to be using? Should you use one that's slightly better? Should you use one, is this the best tool to be using? And if we used another tool that's perhaps more or less accurate, are we going to get a better result? We've had a question about 9001 and how this standard, because when people are going to be buying the standard, is there a need to buy it? Customers only ask for 9001. I believe that that will change, and I've had a talk to, as part of my work on doing other BSI stuff, and our German colleagues, my German colleagues told us that that Airbus are going to insist that 10012 becomes the mandatory standard for Airbus. And my defence colleagues are taking the same view of life. So I believe that it's going to become a standard that's going to be out there. Have you any thoughts on that, Dom, Sharon, as people would buy things?
I think ISO 9001 still has paragraph 7152 about measurements. And I think this kind of ties directly to that paragraph. And Sharon, you may disagree with me on this, but I think what it looks like on this is 7152 defines certain things you should do. The auditors really have no other information on what to analyze in ISO 9001. It just kind of left that statement hanging. 10,012 fills in the missing components of that statement and allows an auditor to know what they're looking for, as opposed to 7152, which is, I think, two and a half sentences stuck in the document and never really explains itself anywhere.
I would agree with you on that, Dom. I think 9001, when you have an auditor auditing 9001, that element, it is not knowing where that steer is. What is it they're going to ask for? What is it they're going to look for? If you don't ask for the right things, you're not going to look at the right things, and therefore you're going to get a false assurance that everything is as it should be. Whereas with 10,012, there is that clearer steer of what an auditor should be asking, what they should be looking for, and what they should be assessing.
We've also had the question of, does this standard cover AI? It covers cybersecurity. It may, under the 8.1.2 that we'd said earlier, it says that we need to take into account cybersecurity as part of the product. So when I'm making something, I need to ensure that the firmware inside it, that all the software that it's using is all the correct firmware and the correct software. So it doesn't cover AI in that sense, but it covers cybersecurity, and it was cybersecurity was considered important in this one.
I think to also add there, Alistair, though, AI is often involving algorithms, and any piece of equipment that needs an algorithm associated with it needs to have frequent calibration checks on the algorithm as well to ensure it hasn't deviated from what it should be giving out.
Well, the other thing where it becomes important is embedded software in instruments.
Yes,
is a very thing that
that's one of the things that we said.
I'm sure is going to see more adjustments with AI available, where it can be done, and I'll use the term loosely, and nobody get mad at me, more easily. But I think that AI is going to drive more functional changes to embedded software over time, because embedded software is something, as much as we don't realize that we're using every day, and almost every instrument we touch that isn't mechanical in nature. Because nowadays it's so easy to put a microprocessor in an instrument and let it do a lot of the hard, heavy lifting work of taking the measurement. So it's important to understand that that's where AI is probably going to have an effect. We did not specifically treat that in this standard. Truthfully, when we started writing the standard, AI wasn't advancing as fast as it is now, and we couldn't anticipate where that would go. So I'll say it that way.
We're now into the end part. Would each one of us has a chance to make a 30-minute statement on what you think of the standard. Starting with Sharon, you got something you want to, closing remarks, Sharon?
I think it's important to emphasize the difference between 17025 and 10012. They're not, it's not to replace 17025. They are very different, and they have different uses and different implementations, and I think the two are very different. And I think that's an important point that individuals need to remember.
Dom?
I think that the advantage of this standard is it helps an organization plan their business operations and their engineering operations in such a way that they result in driving the best product to their customer and doing that with the least amount of waste, which I know is a big discussion topic in the US and the quality business now. I think that we've tried to make an attempt to make sure that firms can use this standard to improve their business. We're not trying to be onerous, and I should make a note, I'm going to just say it here, Alistair. Working Group 27 received an instruction from TC 176 to make this a Type A standard.
Yes, we did.
That's why it's a Type A standard. There was the feeling at a higher level at TC 176 that there was a need for this. And as such, the working group took that seriously and has tried to build a document that is usable and has enough information in it, as you notice by the number of notes and number of bibliographical references, that'll help people get to the point where they can use it properly without being too onerous.
In closing, I would just like to say a couple of short things. Firstly, this standard is to involve everyone. It means that the people on the shop floor making a measurement need to understand why they're making the measurement. They're not just, we don't treat people like cattle. This is about people making measurements and why they're making the measurements. And we need to understand the uncertainty behind it. We need to understand all of that stuff. It's all about production people, design people. It brings this quality from them out into the production environment, and it will drive up standards because everybody will get involved in it. It's a standard not just for metrologists, it's a standard for everyone. And the question that we had is, every lab can set up and do something like this. It will drive innovation, it will drive quality. And now I'll hand back to April, who has some thoughts for you in the minute and a half we have left. Sorry, April.
No problem. Thank you so much again, Alistair, Dom and Sharon, for that Q&A session and your presentations. And thank you very much to our delegates for submitting your questions today. I'm aware we couldn't get through all of them, but we will do our best to email you some responses afterwards. I do have a couple more slides. So maybe if we go to the next one. Thank you. Hopefully you'll be leaving today with a better understanding of what the changes of the soon to be published ISO 10012 will be, and whether you're a long-term user or if you're new to the standard. So I just wanted to share a couple of links. So as mentioned earlier, ISO FDIS 10012 is available to buy as a pre-order through BSI. And once the standard is officially released, you will get a copy of the published standard at no extra cost. And you can find the link at the top of the page there. We also have a special discount code for webinar guests today. So if you enter the code that's on the screen at the checkout, you can receive 20% off. Just to highlight as well that Alistair's produced a white paper on ISO 10012 for BMEX, which is available for download via the second link there. Next slide, please. And lastly, if you'd like to find out more about how you can get involved in standards making, please do get in touch with your national standards body, which will be BSI for those of you who are based in the UK. You can just click on the link there to find out how you can take part. And that brings us to the end of our session today. So thank you very much again to our speakers, Alistair, Dom and Sharon, to all of you delegates for attending. Have a great rest of the week.
Thank you for coming, people.
Thank you.
Thank you.
Thank you.